Good morning, madam. My name is T. Bashit. I am studying CSC and DS. Today I am here to say CA1 assignment, verify Taylor's theorem. For f of x is equals to 1 minus x power 5 by 2 with Lagrange's form of remainder up to two terms in 0, comma 1. Subject name LAC, subject code 23, mat 01. Taylor's theorem. It states that a function f of x that is sufficiently differentiable near a point alpha can be expressed as a polynomial is known as Taylor's series. That theorem f of x is equals to f of alpha plus f inverse of a into x minus alpha plus f double dash of alpha by 2 factorial into x minus a whole square plus and so on f of n into alpha by n factorial x minus alpha power n plus Rn, where Rn is remainder term given by R power n is f of n plus 1 into c by n plus 1 factorial x minus a whole power n plus 1. And the next, Lagrange's theorem. It is also known as mean value theorem. It states that if a function f of x is continuous on the closed interval a comma b and also says it's differentiable on open interval a comma b, then there exists at least one point c in a comma b such that f inverse of c is equals to f of b minus f of a by b minus a. And the question is, verify Taylor's theorem for the function f of x is equals to 1 minus x power 5 by 2 with Lagrange's form. Remainder up to two terms in 0, comma 1. Given f of x is equals to 1 minus x by power 5 by 2 in 0, comma 1. Here n is equals to 2 and x is equals to 1. From first f power n minus 1 into x is equals to, we know that n is equals to 2, so substitute n value 2 in first one, f2 minus 1x is equals to f1 x. It is continuous in closed interval. And second is f power n of x is equals to f double dash of x. It is also differentiable in open interval, so it satisfies the conditions of Lagrange's theorem. And by Taylor's theorem, with Lagrange's form of remainder up to two terms in given by f of x is equals to f of 0 plus x f dash of 0 plus x square by 2 factorial f double dash of theta x. Equation 1. R power n is equals to x power n into 1 minus theta power n minus p f power n of x by n minus 1 factorial into n. R power Rn is equals to x power n into 1 minus theta power n minus p of n of x by n minus 1 factorial n. F of x is equals to 1 minus x 5 by 2 from question. F rho is equals to 1. F dash x is equals to 5 by 2 into 1 minus x 5 by 2 minus 1 into minus 1. By doing is we get answer is equals to minus 5 by 2 into 1 minus x over 3 by 2. F dash of 0 is equals to minus 5 by 2. F double dash of x is equals to minus 5 by 2 into 3 by 2 into 1 minus x power 3 by 2 minus 1 into minus 1. We get the answer is 15 by 4 into 1 minus x power 1 by 2. F double dash of theta x is equals to 15 by 4 into 1 minus theta x power 1 by 2. From equation 1, we get 1 minus x of power 5 by 2 is equals to 1 plus x of minus 5 by 2 plus x square by 2 factorial into 15 by 4 into 1 minus theta x in whole power 1 by 2 at x is equals to 1. 0 is equals to 1 minus 5 by 2 plus 1 by 2 into 15 by 4 into 1 minus theta power 1 by 2, and 15 by 8 is equal 15 by 8 into 1 minus theta whole power 1 by 2 minus 3 by 2 is equals to 0. We want to send 3 by 2 at that side. 15 by 8 into 1 minus theta power 1 by 2 is equals to 3 by 2. Next 1 minus theta power 1 by 2 is equals to 3 by 2 into 8 power 8 by 15. 3 15 cancel to 8 cancel. So finally we get 4 by 5. 1 minus theta whole power 1 by 2 is equals to 4 by 5. We want to send 1 by 2 that side, then it squares 1 minus theta is equals to 16 by 25 minus theta is equals to 16 by 25 minus 1. Here minus theta is equals to minus 9 by 25. Minus minus cancel. Theta is equals to 9 by 25, which is 0.36, which is less which is between 0 comma 1. Hence Taylor's theorem is verified. Thank you. Thank you. This is presented by Bashit from CAD A section.